Hello everyone, this is Sumita Gupta. Welcome you all for my next lecture, that is MCQ on large signal amplifier, low and high frequency response amplifier and the differential amplifier. Okay, so we'll solve some MCQ question with the explanation. So first question is, why do we use CE amplifier as a large signal class A power amplifier? Now remember, C means common emitter amplifier, large signal class A amplifier. If they are talking about large signal, means they are talking about the power amplifier. In power amplifier, if you remember, there is a classification of A, B, AB, C amplifier, D amplifier, like that. Okay. Always remember, small signal amplifiers are voltage amplifier and large signal amplifier the power amplifier. Now, caution is that why we only use CE amplifier as large signal amplifier? Why not we use common base, common collector? So reason is that CE, that is common emitter amplifier, that is a basically high voltage gain amplifier. So what is the use of high voltage gain? If it is having high voltage gain, means it can handle high voltage as an input, means it can handle the large signal. That's why we use always common emitter amplifier. Okay, due to impedance, no. Due to student, no. So main correct answer is due to high voltage gain, we used common emitter amplifier. Okay, for large signal. Now, what does class A amplifier do? Now remember, whenever we are talking about the class, we are talking about the power amplifier. Now, what is the role of power amplifier? Deliver the power. So definitely answer is delivers kilowatts of power, not voltage, not pressure, not resistance. Since it's a power amplifier, so it delivers the power only. Okay. Now, what is the efficiency of class A power amplifier? Power amplifier is not mentioned, but still class A means it's a power amplifier. So if we talk about the efficiency, so efficiency will be like this. For A, it is efficiency is between 25 to 50. Means if we'll use normal class amplifier, it will 25% to 30%. If we'll use transformer coupled, then it will be increased by 25%. That it will be than 50% efficiency. For V, it will be 78%. For C, it will be more than 90%. So for class A, we'll talk about the efficiency will be 25 to 30%. Okay, so as per the option, no 75, no 100, no 50, so efficiency is 30%. But if you will do the ideal calculation, it will be 25%. Okay, so well, we can say in the power amplifier, the class A power amplifier is a less efficient power amplifier in terms of efficiency. Okay, now again, which of the following statement is true about class A amplifier? Now it should be in your mind that class A power amplifier is a less efficient power amplifier. Less efficiency, that efficiency is very minimum, 25 to 30%. So it cannot deliver 100% power. And since its efficiency is less, it's not more efficient. If efficiency is less, it cannot suppress signal. So it is weak against any type of distortion, any type of noise. So answer is they are weak against distortion. Now, what is the need for heat sink in the class A amplifier? Remember, class A means we are talking about the power amplifier. If power amplifier, we are talking in terms of power only. When there is a power, then there will be heat sink, because we have to control the heat, we have to control the power. So heat sinks required to control the heat dissipation. Okay, more power will be there, there can be some wastage also, so we have to control that dissipation. So for control of any type of dissipation, we need the heat sink. So heat sinks are required in the power amplifier, remember. Okay, now the next question is, DC power for class A power amplifier is 500 watt and AC power is 200 watt. What is the efficiency? Simplest efficiency expression is AC power divided by DC power. AC power divided by DC power. What is AC power? AC power is given 200 and DC power is given 500. 200 divided by 500 multiplied by 100, because we are calculating in terms of percentage. So it will be 40%. Okay. Now next question is, which of the following technique is used to increase the efficiency of class A power amplifier? Remember, class A power amplifier is normal like a common emitter amplifier. In common emitter amplifier, if you remember, this is voltage divided network, this is your common emitter amplifier, or we can say power amplifier. But its efficiency will be 25%. If you want to see the derivation, you can watch my previous lectures. Okay, I have explained the whole derivation of it. Now, if this is collector, if we replace this collector resistance through the transformer, then it will be increased up to 50%. Okay, derivation you can watch in my previous lecture. So that is the reason we use transformer in the class A power amplifier if you want to increase the efficiency. Okay. Now, what is the conduction angle of class A power amplifier? Remember, conduction angle related with Q point. Okay. In class A power amplifier, Q point is exactly at the midpoint of load line. If Q point is exactly at the midpoint of load line, then no portion of output waveform will be clipped. No portion will be clipped. So what is the conduction angle? 180. 180 means total conduction angle is 360. That is for class A power amplifier. If we talk about class C power amplifier, okay, I'll discuss later. Okay, understood? So conduction angle of class A amplifier is 360. See, this is an example of output sync of class, which class it belongs. Now see, class A is already clear. In class A, Q point is exactly middle of the load line, but in class B power amplifier, Q point is at the cutoff. So now if you draw the waveform, what will happen? Only half portion will become under the load line. See this. Only what will happen? Only half portion coming here. Only half portion coming here up to load line. And here also in the load line, only half portion is a part of it. Half is clipped, half is clipped, half is clipped. So what is happening? We are getting the conduction angle up to half only, means 180 degree. So now check the waveform. In the check waveform, this waveform is incomplete, means we are getting output up to only 180 degree. So it is example of class B. Suppose the waveform will be like this. Then pause the video and then think about what is it. It's a class A because we are getting 360 degree. Okay. Suppose we are getting waveform of less than 180 degree. Then it will be class C. And suppose waveform will be more than 180 degree but less than 360, then it will be class AB. Okay. And if you want in details, please watch the previous lectures. Okay. So the main features of large signal amplifier in the circuit is, remember, I'm continuously repeating, a small signal amplifier are your voltage amplifier and large signal amplifier is your power amplifier. So what is the features of power amplifier? We use for power efficiency, right? Then maximum power limitation, definitely. Impedance matching because we use transformer, so that is also okay. So all of our for the particular question, right? Now, which of the following are power amplifiers? And you know, power amplifiers are A, B, C, and D. These all are the classification of power amplifiers. So class A is also power amplifier, B also, A, B, C, D. So all of our, okay. Why? How much does the output signal vary for class AB? Remember, if you want to remember in the tricks, remember A is exactly middle, B is exactly at cutoff. Then we are talking about AB. AB is middle of A to B and C is below here. Position is like this. Remember Q point. A, AB, B, C. Now you can understand well. If any signal is here, nothing is clipped. Definite. Understood? If any signal is here exactly, so half will be clipped. So for this it is 360 degree angle. And for this angle of conduction is 180 degree. Okay. Now for this more than 180 but less than 360 degree. 180 to 360 degree. And for class C, very less. It will draw the only some portion. Some portion will be in the part of load line. It is less than 180 degree. Okay. So now I'll tell about class AB only. Since the question of class AB, so I have explained you this is the position of A, this is position of B. So AB is the position in the middle. Okay, AB is the position in the, means just above the cutoff. Okay, above the cutoff. This is cutoff. Okay. Now, if we draw the waveform, what will happen? If we draw the waveform, what will happen? The whole 180 degree will get, but for 360 degree. So up to load line, you will get only this part. Other part is clipped. So you are getting more than 180 degree and less than 360. Same here. The waveform is like this. So up to load line, if you want to check, so up to load line, you are getting this part complete and this part complete, but this part is clipped. So in class AP power amplifier, conduction angle is between 180 to 360. Otherwise, you can learn for class A, it is 360 degree. For class B, it is 180 degree. For class C, less than 180. And for class AB, it is 180 to 360 degree conduction angle. Okay. So that is the concept. Now, which type of power amplifier is biased for operation at less than 180 degree? Just now I have explained this concept. For AB it is 180 to 360 and for C it is 180. So for class C it is less than 180. Which amplifiers primarily provide sufficient power to output load to drive the speaker? When talking about the speakers, if the speaker needs high power, we use only power amplifier. Okay. The main feature of large signal amplifier in the circuit is definitely efficiency, limitation, maximum power limitation. I think it is repeated. Next, see, I have already explained you. Now you are getting 180 plus 180 degree, full 360 degree you are getting the output, and full 360 output is always in class A power amplifier. Okay. Now, categorize the efficiency of each amplifier from worst to best. So remember, for A, it is up to 25 degree. For B, it is 78. You can check the derivation. For C, it is more than 90%. And between A, B, there will be AB. And after this is D. So what is the sequence? A, B, C, D. If AB is here, then AB will be there. So A, B, B, C, D. Okay, worst to best. So remember, if best to worst, then it will be opposite. D, C, then B, A, B, A. So this sequence you have to remember. Okay. Now, maximum efficiency of transformer coupled class A power amplifier. You can watch my previous lecture for the derivation. Normal class A power amplifier's efficiency is 25%. When you add a transformer, it will be 50%. I have already explained. Maximum efficiency of class B is 78.5. How many transistors used in class B power amplifier? If you watch the circuit, there are 2 transistors. Okay. Now next is, which of the following are the disadvantages of class B? The class B symmetry push-pull amplifier, there is one disadvantage mainly is crossover distortion. Okay. It needs 2 separate voltage sources. Yes. 2 transistors, 2 separate voltage source. But if 2 transistors will use, if you remember the concept in the lecture, what happened? The transistor cut-in voltage is 0.7, the transistor cut-in voltage is 0.7. That's why there is some crossover distortion left because of turning on the time of the transistor. So to remove this distortion, if you remember, we use the diodes. Okay. So the main disadvantage is crossover distortion, and it does not provide exact switching. Exact switching means exact from 0 to 1. That is called exact switching. Exact from 1 to 0, 0 to 1, because when one transistor is off, second transistor takes some time to on. Okay. What is the maximum rating that you have to learn? 150 to 200 degree. Determine what maximum dissipation will be allowed for 70 watt silicon transistors rated at 25 degrees centigrade if derating is required above 25 degrees centigrade by derating factor at a case temperature. Such type of numerical for these are the formula based numerical. They want power dissipation. Okay, and the derating factor is there. So remember, for derating factor, whatever initial temperature you have given, that power minus difference of temperature. Temperature 1 minus temperature to, wait a minute, again listen, you want to calculate power dissipation. The expression is uh, power dissipation at given some initial temperature. Suppose I'm taking T naught minus difference of temperature T1 minus T naught multiply by derating factor. So now what is given here? Initial rating temperature is 25 degrees centigrade. At the temperature, the power is 70. So there will be 70 minus difference of temperature. Case temperature is 100 and the rated temperature is 25. So 100 minus 25 is 75. Multiply by derating factor is 0.6. Now solve this. 70 minus 45.0 means 45. So it will be 25. So answer is 25 watts. So this is simply formula reasoning. Okay. Now a silicon power transistor is operated with a heat sink theta SA 1.5 degree centigrade per watt, transistor rated 150 watt, theta GC, and the mounting insulation, all parameters are given. What is the maximum power that can be dissipated if the ambient temperature is 50 and junction temperature is 200? So for such type of numerical means now we have used the heat sink in the power transistor. When we attach the heat sink, then the formula of the heat dissipation, power dissipation is difference of the temperature means junction temperature minus your case temperature. Okay, that is divide by all type of heat sink coefficient, that is theta SA plus theta JC plus theta CS. Okay, so now solve it. 200 minus 25. Okay, junction temperature minus this, and solve it. So junction temperature is 200 minus this will be ambient temperature. Ambient temperature is 50. 200 minus 50 divide by 1.5 plus zero point 0.5 plus zero point 0.6. Pause this video, watch this, solve this and check. You will get 57.7 watt. Okay, so you can check these numericals are given in the book of Bolstead or Settles. Okay, the beta of power transistors, remember, normally beta is high for small signal means voltage amplifier, but for power transistors beta is less than 100. Okay, greater the power handled by the power transistor, definitely if we are handling the more power means we are handling the high temperature. Okay, now next, the which has the hottest temperature in the power transistor? Definitely for any transistor, junction temperature is always high. Okay, always having the highest temperature. A heat sink provides low thermal resistance between case and air. Hmm? Which power amplifier is limited to use at one fixed frequency? If you remember, the class C power amplifier has the less than 180 degree angle. So it is used by one fixed frequency. It is limited to use for one fixed frequency. Now next, if MOSFET is used in the making of amplifier, then it must work in which region? Remember, there is a difference between BJT and MOSFET. For BJT, always uses active region as an amplifier, but MOSFET used as an amplifier in always in saturation region. If you want VGT like a switch, it must work in cutoff and saturation. But if you want MOSFET as a switch, it should work in cutoff and the leader. Okay, detail you can watch in next. The same thing, if MOSFET you want to use as a switch, so it should be used in MOSFET as an amplifier used in saturation regions. Apart from saturation region, what are the regions? Cutoff and the triode region. Cutoff region behave like a off switch and triode region behave like a on switch, right? Next, a differential amplifier. should have collector resistance value, RC1, RC2, these are the options. Remember that for differential amplifier, collector resistance values are not fixed. But you should learn this concept. This is your differential amplifier. Okay. So there are two identical transistors we used. So what that for that those transistors, these two values should be same. Whatever you are taking, 1K, 2K, 3K, this is 2RA, 2K, 3K, 4K, 5K, whatever. But both values should be same. Now in this case, 5, 10 different values. 5 ohm and 5 kilo ohm, again different. 5K, 10K different. So only this is your correct answer. But there it can be given 10K, 10K. It can be given A, comma A, B, comma B. So remember the values are not fixed. But for differential amplifier, both resistance should be same. Okay. The value of ammeter resistance, ammeter bias circuit. We will talk about ammeter bias circuits. What will happen here? Two resistors we connect in parallel, RE1 and RE2. So what is the equivalent resistance? Definitely RE will be RE1 parallel RE2. What is the parallel value here? We just want to calculate this. RE1 is given, RE2, what is RE? So 25 multiplied by 16 divided by 25 plus 16. Always remember, we are not changing the unit, it will be in kilo ohm. So just pause the video, solve this and check whether you are getting the correct answer or not. Okay. If output is measured between two collectors of transistors, then the differential amplifier with two input signals said to be configured as. Now remember, for differential amplifier, okay, these differential amplifier means we are applying two inputs and we are getting output at RE. This will be RE. Okay, applying inputs at two terminals and we are getting output at two terminals. Differential amplifier means just difference of input signal. That's it. Differential amplifier means output is the difference of two input signals. But it four categories: dual input, balance out. Dual input means we are applying input at both terminals. Okay. If we are applying one term input at one terminal and other terminal ground, that it will be single input. Got it? So dual input means we are applying input at both terminals, then it will be dual input. If we apply input at one terminal, another terminal is ground, or we are applying input at the second terminal and first terminal is grounded. We are applying input here and the first terminal is grounded. Then also single input. Now, what do you mean by balanced and unbalanced? If we are getting output at both terminals, then it is balanced. And if we are getting output at one terminal only, then it is unbalanced. So there are four type of category. What is dual input balanced output? Means we are applying input at both terminals, we are taking output at both terminals. Dual input unbalanced output means we are applying input at both terminals but taking output from the one. Single input means we are applying input at one terminal but taking output at the both terminals. And dual input unbalanced, single input unbalanced output means we are applying input at one terminal and taking output one terminal. Okay. So what is a perfect? Perfect is when applying input at both terminal and taking output at the both terminal. So what is asking the question? Output is measured between two collectors. Means we are taking output from both terminals. It's a balance. And two input signals means we are applying input at both terminals. Means dual input. So it's a dual input balancer. Differential amplifier is a capable of amplifying definitely AC and DC both type of signal. It can amplify. In either differential amplifier, same signal is given to both input and output will be. Since I am talking about differential amplifier, output is proportional to difference of input signal. So if both signal are same, suppose 1, so 1 minus 1 is 0. So output will be 0. Okay. The difference output of basic differential amplifier is taken as definitely if there are two terminals, suppose X and Y, then difference of voltage between X and Y is your output. Okay, there is no one ground. We are talking about difference output of basic differential amplifier, then we will take both the terminals. Difference output of the different amplifier, the amplification of different voltage applied to different terminals. Okay. Now, what is the maximum and minimum output differential? Remember, for any type of amplifier, maximum voltage always is up to power supply. You cannot cross that. Okay, for any type of amplifier, the maximum signal, so it is given in all the options. Then how you will choose? So choose with the actual output. Suppose this is your circuit. In this circuit, this is your wait a minute. Suppose this is your circuit. Okay, this is your RC, or this is your power supply DCC. Here it is your output. What is the output? Output will be VCC minus ICRC minus V naught equals to 0. If we are talking about the BJT. Okay. If we'll talk about FET, if we'll talk about FET, then there will be, see, it will be like this. FET or MOSFET. So there will be RD here. And in the power supply, there will be BDD. Then what is the equation? Equation will be BDD minus ID RD minus V naught equals to 0. So what is the maximum voltage? VDD minus IDRD or VCC minus ICRC. So see here, this is not the case. This is not the case. VDD minus IDRD. VDD minus IDRD this. Or here it can be VCC minus ICRC. So these two are limits. This is your actual output. A maximum output can be power supply. Okay. Obtain the collector voltage for collector resistors. I is given and BC is given. That's simple. Simple means we are talking about collector voltage. What has happened? Collector resistance given 5.6K and supply is given 10 volt. Okay, and this resistance is not given, but IE is given, that is 1.664 milliampere. Okay, so you have remember single input all balance output means you are applying input at one terminal, you are taking output at one terminal. It is single input, single output. So this is your BC. This is your BC. What they want? This BC. Okay. Now just apply KVL here. 10 minus 5.6 IC equals to BC. Okay. IB is not given here, so we assume I approx equals to IC because beta is also not given. Okay. So here just put the value of current. You will have the value 0.682 volt. Okay. Why? What other means are cutoff frequency and the frequency response? Now talking about the frequency response. This is your frequency response. Okay. So these are your corner frequencies. Either you can say corner frequency, you can give break frequency because break point is there, or it is square half power frequency. So all are the correct options. So don't be confused. What is the ratio of output voltage to input voltage at cutoff frequency? Remember this if you have done previous or you have drawn any response in that practical also. This is basically, if you remember, this gap is always 0.707 in normal value. If you calculate it, it is minus 3 dB slope always. Here also same here. Either it is 0.707 or it will be minus 3 dB slope. Okay, so that is easy, very easy. Okay, so what is normalized? As I already explained, either it is 0.707 or minus 3 dB, right? The larger capacitive element of design will determine capacitive element. Capacitive element, what is the reactance? 1 upon j omega c. Okay, 1 upon j omega c. Omega is your 2 pi f. 1 upon j 2 pi f into c. Now relation between f and c. Relation between f and c is opposite, inverse proportional. So if f is increased, c will be decreased. If c is increased, f will be increased. So larger capacitance c increases, so f will be decreased. So large capacitive element will determine the low frequency. A smaller capacitive element will determine the high frequency. Okay. Change in frequency by a factor of equal to 1 decade. If you remember the Bode plot, frequency response, so what is the slope is minus 20 dB per decade, minus 20 dB per decade, minus 20 dB per decade. Decade means ratio of frequency is 10. Therefore, it's a F1, it is a F2. So ratio of F2 by F1 is 10. That is called decade. Okay. Which of the following capacitors including CI for the high frequency region? For high frequency, remember in the frequency response, gain is constant in the mid frequency range. In the low frequency range, gain reduces due to coupling and bypass capacitors. In high frequency range, gain reduces due to transistor internal or wiring capacitors. The first is wiring capacitors including high frequency, correct. Transistor internal capacitors, correct. Miller capacitors, correct. So all are the part of high frequency response. In a hybrid model, that is also called here called like a model, which one of the following does RB include? So RB is base resistance. You can call it base spreading, you can call it base contact, you can call it base bulk. So all are the names of RB which we include the hybrid pi model. Which of the following configuration doesn't involve the Miller effect capacity? So remember, Miller effect is normally used, generally it is used in common emitter, sometimes we use common collector, but we never use it in common base. Okay. A 3 dB drop in HFE, HFE is like beta, current gain. A 3 dB drop will occur at a frequency that is F beta, remember. Okay. F beta is a frequency when gain is dropped by 3 dB. What are range of capacitor in CGS CBT? Remember, there are two types of capacitor in the circuit. One is transistors, internal capacitance. This capacitance, suppose this is drain, this is gate. So this will be CGD. Okay, here it will be CGS, or here it will be CDS. These all capacitors are in picofarad range. Okay, and the one capacitance connected here outside, coupling capacitance, bypass capacitance, those are in microfarad range. So in short, coupling and bypass capacitance are microfarad range, but junction capacitor, transistor intercapacitance are in picofarad range. Okay. Okay, so these capacitors are picofarad range. So again, the question CDS value. So whatever value is CDS is, drain to source resistance, that range is 0.1 to 1 picofarad. You have to learn. Okay, in the RC coupled amplifier, the drop in gain at low frequency. I have already explained you the gain and drop in the low frequency due to coupling and bypass capacitor. So all are the part of this, and it can be common emitter, common collector, common source, or common. Okay, means it's a common. If source we are talking about, it's about FET. If emitter and collector is a part of BJT. Okay, but all are the responsible for decreasing the gain. In the input RC circuit of single stage BJT or FET amplifier, as the frequency either increase or decrease, capacitor resistance increase or decrease, and more or less of input voltage appears across the output terminal. Remember, these two portions are opposites of nature. Means increase, decrease, decrease, increase. It can be. Okay, so increase, decrease can be, or decrease, increase, decrease. It can be, but both should not same. Both is not same. Okay, because I have already explained, if frequency increases, then capacitance will be decreases, or opposite. If frequency decreases, capacitance increases. But if frequency increases, then input voltage appears at the output terminal will be more or less. Definitely for high frequency, high input voltage will be there. So option is increases, decreases more. Change in frequency by a factor of 2 results in the change. Now we are changing frequency by a factor of 2. But in gain, what will happen? In gain, we take 20 log base 10. So if you calculate 20 log base 10 2, it will be 6.02 dB. Change by 2 normally in dB, it will change by 6 dB. Okay, a change in frequency by factor of 10. So 20 log 10 is 20 dB. So it will be 20 dB. Correct? In the low frequency region, the low frequency cutoff frequency determined by CS, CSC will have the greatest impact on the network. Okay. So remember, for low frequency will take highest value. For high frequency will take the lowest value. Don't forget this. Okay. For any inverting amplifier, the impedance capacitance will be seen by Miller effect, sensitive to gain of amplifier electrical capacitance. Remember, whenever we talk about the Miller effect, due to Miller effect, it decreased. The impedance capacitance decreases. What term is the meter and volts gain assigned value 1 or 0? That is, we'll take the normalized value for the dB. An amplifier has the input signal 0.054 millivolt, output is 12.5. The voltage gain. Voltage gain is output by input, means 12.5 divided by 0.054 millivolt, means 10 raised to minus 2. But it is not enough. After this, you have to, what you have to do? You have to take 20 log base 10. 20 log base 10. When you will solve this, then you will get 107.3 dB. The capacitor C1 affects. Now remember, I have already explained you, in any frequency response, for mid frequency all the capacitors are open circuit for AC analysis. For low frequency, coupling and bypass capacitor come in. So C1 is your coupling capacitor, C2 is your coupling capacitor, C3 is your coupling capacitor. So all three effects are low frequency response. Okay. Now what is C3? Again C3 is for low frequency response. In the previous figure, the capacitor CBE. If we talk about CBE, means here there will be capacitor. That is your transistor internal capacitor. And transistor internal capacitor affects your high frequency response. Okay. A roll off of 20 dB per decade. Remember, decade is of 10, octave is different. So for octave, it is 20 dB in decade is always equals to 6 dB in octave. Okay. Doubling the voltage gain causes always, I have remembered 20 log 2 is your 66 dB. So if you double the gain, it will increase by 6 dB in the decibel. 6 dB increase. Okay. So thank you so much. Hope you will like this. Please do practice. Share with others. If you have any doubts, you can message in chat box. Okay. Keep learning. God.